Good afternoon, everyone, and thank you all for joining us today. My name is Rashmita, and I am the event planner for Microsoft Reactor India. This session will run over the next 60 minutes, including Q&A. But before we begin today's session, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section will be open throughout, and we do encourage you all to participate. So please feel free to drop all your questions in the chat section. I would now like to welcome Dr. Ravi, our speaker for today's session. Dr. Ravi is a director of AI and emerging technologies at Compunnel and Forbes Technology Council member. But for now, I will hand over to him to begin the session. Let me bring him into the stream. There
Thank
you
you,
go.
Rashmita. And yeah, hi, a very good afternoon, good morning, good evening, everybody. Thanks, Rashmita, for a wonderful introduction. And before we go ahead, I would like to discuss that the entire agenda we're gonna, discuss is around cloud and data center optimizations. So we'll be discussing more on sustainable FinOps and AI for climate action practices for the global good. And before we proceed ahead, let me have a quick sanity check. Am I loud and clear?
Yes, you are.
Okay, and the screen is also visible to the audience.
Yes, yes, it's up.
Perfect. So now let's begin with the agenda, right? So the agenda is all about cloud and data center optimization, and here we see there are two things which we are working upon: the climate technologies and also work, being worried about the financial optimizations. So how do we save our efforts, time, money, and efforts over there in cloud practices, data center operations, and all, and how do we work out on the kind of climate action workarounds? So that's the case. Before we go ahead, let's see to the agenda what exactly we're gonna work out with, and I'll also display certain innovations which exactly are there. Before we go ahead to the session, the entire discussions we're gonna have is on the overview that what exactly is the FinOps all about, the climate action all about, the kind of sustainable practices which are there for cloud monetization and optimization are all about. We are going to talk about sustainable cloud operations, why it matters. We'll deep dive with FinOps, GreenOps, and sustainable cloud practices. We'll see to it the energy and emission optimization techniques, and we'll have a deep dive demo on walkthrough for the Microsoft Azure platforms, tools, whatnot, right? And also we'll be having the AI powered insights for cloud optimization. In the end, we'll be having the implementation strategies and best practices for a global good. And irrespective of the business domain or industry domain, we'll be having those particular things in check. So let me begin with the framework in this direction. What exactly are the innovations all about, and what are my recent contributions? So as you can see that I had been working with different firms as a subject matter expertise in terms of steering committee, be it EI steering committee, fractional chief AI officer as a service kind of a platform workaround, or it could be my roles and responsibilities at Forbes Technology Council in terms of ethics and governance. So I'd been contributing to EY, PwC, KPMG, the organizations which are already big threes, and TCS, then the other platforms which I worked where the World Bank and all, where I held the industries to have the configured solutions in terms of the best in class practices of AI and machine learning operations. So in certain areas, when it comes to the FinOps practices and data center optimizations, certain innovations were there. It is not only targeting the cloud data practices, or let's say cloud machine learning or AI service practices. It means that anything which comes on the way when you're consuming the cloud services, it could be cloud computing, it could be fog computing. I hope everybody is aware that we can work also save efforts and monetary aspects when we work on fog kind of computing frameworks. So those particular areas are being covered up. But beyond that, also the planetary sustainability, if we talk about, there are certain innovations I am working and have been worked upon with certain patents there. So we started with a kind of a submission over there at reputed ITU journal, that is International Telecommunication Union Journal, where I have given a framework that how exactly we can have an agentic AI along with a generative AI framework and sustainable emission monitoring and management system. So The current sources which I found that they were very much either on a human side or on a machine side. There was no integration or alignment to each other. The major problem I also found that the data quality was having certain issues. There was no data which was available to track and monitor the entire emissions, be it coming from the industries which are actually energy producer, or be it the the forest fires where exactly the emissions comes out. So there was no proper mechanism by which we can see that this is what the systematic framework we can implement, and we can monitor the emissions over a period of time for the entire planet. What I've did is over there in my innovation is that we can have the data sources which include satellite data, IoT sensors, human activity data. It could be drones and the other basic sensor based mechanisms as well. And to the high level, you can see that it could be the satellite data which has remote sensing based mechanisms to keep a track on the entire planet and can move around that, hey, where exactly the emission is coming from, and it's to what level the emission is happening, right? There are multiple ways which I can demonstrate. Now then, there is a data integration layer which exactly is kept to have the data sources right in place, get this particular data integrated with the AI modeling layer, where we can have agentic AI operations which has autonomous self-learning mechanism, which I'll discuss at detail once we go ahead further for the session. In the explainable AI domain, we can get it more what we can say explainable, and at the same time it can have best in class anomaly detection system or industrial optimization as a business unit also we can keep a track upon. There are certain platforms which I'll discuss, like a generative physical AI layer could be there, which can work on some platforms which are apart from Microsoft. We need to also work on some certain open sources. Microsoft already having its now AI Foundry, and along with that, it also in the Ignite they have recently introduced the services which is agentic AI services. So those also can be definitely leveraged here. And there is a decision making layer which comes with policy simulations and real time decisions, and there you can see that we have a better output and feedback for the entire monitoring of the ecosystem. Don't worry, going to discuss this all in detail. So that's only kind of a high level just framework which I'm discussing right now, which I recently submitted. Now, if we talk about the session, the major overview, if I want to give on the entire, let's say, pool of services and the offerings we are going to discuss today, and how as a developer, as a the community member within Microsoft Reactor, I should leverage this particular session in terms of how I can excel myself in terms of offering these services, develop these platforms, work out either in the cloud side, AI side, machine learning side, agentic AI side, or even at the data center side, how exactly you can contribute there. So that's what the major key takeaway would be. It is not only aligning artificial intelligence along with the climate tech, it is also aligning you with how we can have the FinOps based practices. It means that sustainability with respect to the emissions and, let's say, the planet aspects, at the same time sustainability with respect to the finance operations, right? Or let's say the kind of the cost aspects. So therein we call it the kind of the optimization for the cloud energy usage. We How we can work out on greenhouse gas emissions. First of all, what exactly is that? I'll also give a kind of a brief over there. And how do we minimize the digital waste? And lastly, we'll be focusing on actionable strategies, best practices, AI driven insights for enhancing cloud efficiencies from financial and environmental perspectives. So before we go ahead, is there any question coming in, Rashmita?
No, we are good.
Okay. So let me take it to the next thing, where exactly the major objectives of the sessions are mentioned. So the major objectives behind working on this particular platform and the today's session is to have uh, what exactly. I think there is some distortion in the font, but let me do that. So at least then we are good. All right. Might be some configuration issues. So what exactly we're going to understand here is that the first understanding would be on the significance of green operations. What are the green operations? What are financial operations? We'll see to that. What is a cloud optimization framework? That we'll also see. We'll learn how exactly we can leverage AI for actionable energy and emission reduction. We'll explore real world techniques to monitor and reduce emissions. How do we cut cost? How do we manage digital waste? And we also discover Microsoft tools for this, for energy efficiency and sustainable cloud operations. So that's the major objectives of the entire session we have. If I talk about the next level work counts on the key takeaways, so after the session you'll be able to have holistic cloud optimization practice with you. It means that you would be able to align your financial and the other operational efficiencies with the sustainability goals. That is imperative from the United Nations. That is the imperative from government. That is the imperative from let's say the industry per se. So those kind of actionable insights you would be able to manage. Implementation roadmap would be given so that you can practice the how we can embed these kind of solutions into cloud strategy. That also could be there, but depends on the maturity of uh, the cloud service which we are using. At the same time, the adaptation to that given cloud environment would also be important decision making point. We'll also see some kind of hands-on demonstration of Azure's sustainability tools and dashboards so that you can make efficient use of these kind of let's say platforms, and at the same time you can readily develop these solutions as well. If you go to the next, we have the very important questions in front of us, right? What exactly is the significant aspect on sustainable cloud operations? Why it matters? So in the segment, if you can just put it over there in the chat, that for you, what exactly are the major reasons why exactly we need to be bothered about sustainable cloud operations? So when we say cloud operations, they are there, right? They comes with their own cost, their own efforts. But when we say sustainable, it means that it should be for a global good, where when we are having the cloud practices, definitely the emissions going to happen. You know that these greenhouse gases basically are emitted, with respect to different actions, be it your a burning of coal or charcoal, be it using any kind of a fuel over there. When we talk about your home appliances, they also emit. So what exactly is there to understand is how cloud operations can be even more sustainable when it comes to monitoring them, and at the same time what how do we optimize them. And to get into that level of understanding, we need to see first of all why it exactly it matters, right? What are the major challenges the entire world is facing, why this particular agenda is very much important for everybody. This session itself is basically helping us to understand that the critical aspects of the environment are happening. Nobody is now uh, you know free from these kind of toxicity in the air, the climate shifts which exactly we are working upon. So as soon as we revamp these strategies to curb these kind of emissions, uh, things would be better. Otherwise, what will happen is, that, right? There would be entire, let's say, deplete in terms of the oxygen level. There would be huge, the kind of forest fires which you would see in coming days, and no icing also would be there. It's recently happening, right? So no icing would be meaning that the global temperature would rise like anything, and it would be difficult to survive. So that's why this particular session, please take it as a kind of a noble course for you, your understanding, and how with your software practices, hardware practices, or let's say cloud practices, you can keep your customers, keep yourselves, and let's say the entire industry, planet green. That's what exactly is the major agenda. Anything before we go ahead comes to your mind, or you would like to want me to discuss over there in the discussion, please? Do you have anything from the team, Rashmita?
No, please
Okay,
carry on.
perfect. Now I think the screen is up and running for everybody, and we are able to see with the fine-tuned version. So, sustainable cloud operations, why it matters. As I mentioned, the very first pointer, if you see, is on global energy consumption. The cloud operations, when it comes through data centers, right? Data center itself, themselves consume around 1% of global electricity, right? This basically is the share which is expected to rise with the increased cloud adoption over a period of time. In coming years, also, you'll see that it's not only 1%, but it would be significant beyond 4 to 5%, right? In coming years, 2030. If I talk about carbon emissions, data centers, they are currently contributing, as per ITU, 2 to 3% of global carbon dioxide emissions. And how that emission happens, that we all aware. When we are using the compute services, when we are working on any even if you are using GPT, right? So that model itself burns the servers like anything. So therefore the heat is generated because of overuse of those machines. And when these machines are emitting heat, coolants are required. When coolant is required, it means water is also required in the data centers. And therefore it's like impacting each other. It's impacting water, it's impacting the oxygen level, carbon dioxide levels, the other gases even. And at the same time, emissions also are harmful for the physical presence of the person. So this is projected to grow by 20% by 2025 if no action is being taken. E-waste, if you talk about global e-waste, is reaching to around 53.6 million metric tons, right, as per the 2021 records. But by 2030, it is expected by World Economic Forum that it would grow to 74 million metric tons. If I talk about water consumption in data centers, there, as per NRDC reports, water for cooling is utilized, and this cooling is vital, and therefore it could also be impacting those areas which are more water scarce regions. So we need to understand that how we identify the maturity of a data center. So that also you can understand from this entire session. Cloud providers actions are there. Google, AWS, Microsoft. We all are aware that there are multiple clouds coming in, right? So now they have achieved 100% of renewable energies, right? Microsoft claimed that we are committed to being carbon negative by 2030. So their PUE scores, I will discuss what is a PUE score, by the way. So that basically is a criterion by which we can understand that by when they can be almost carbon negative. So that's the target. But what happens is because of quantum computing, because of AI machines, right, and because of the generative AI coming in place, generative physical AI going to be the next wave. So all these things are impacting the servers, the data centers, like anything. And though the picture which is on the left side is coming from the known cloud operations, but you can imagine that if it's a 1% also, that would be increasing from our cloud operations. So let's start practicing that. On the left side thing also, we can curb that. How do we curb? Because first of all, we need to monitor and we need to be conscious how we can take those measures. So this is the entire session around that. As per PwC reports, the consumer demand is going to be 79% for the cloud services. Every business now and then want to scale. When they want to scale, they want to use data centers because cloud services come from there. When data centers are limited, people are now looking for the oceans and satellites where they can have those kind of data centers, right? So energy efficient data centers are required. Energy efficient data center, if I talk about, they can also reduce cooling, right, by cost by around 40%. And if I we can save millions annually as well. So it's not only that it's about greenhouse gas emissions, it's also about that how financial innovations can be there to reduce your cost. Cloud's role in reducing emissions is also being seen that cloud adoption can reduce significant organizational carbon footprints also by 30%. That's by 2025, the next year only, right? Now let's see what exactly are data center emissions and digital waste challenges which we are facing right now. Because once we understand these particular challenges, then only we can develop solutions. So I'll come to the coding part, I'll come to the display of the platform part, the platform engineering. But before that, we need to be very much critical about that. Whatever softwares or hardwares we are using, they comes with a cost. The cost to the climate, the nature, and the cost to the company. If they both are aligned, it means that we are 100% efficient in terms of our coding practice, development practice, and anything, right? So as a data center emission and digital waste challenges, some of the challenges have been jotted down by me, and what I have done is I have identified certain solutions which can be deployed for that. The very first problem statement which I found as per the research papers and the global intake of the client workarounds which we work with. So high carbon footprint of data center is the first thing which I found it is should be targeted, right? Number one, the major background behind this is that cloud computing is revolutionizing industries. Industry demands are there because of growing population and like a lifestyle of a person. Per capita income is increasing. So the growing demand for cloud services is also increasing. Ultimately, these data centers are then emitting like anything. Because if you see your local machine also, which you are using, a mini laptop or any mobile, with the 5G and all, you would see that the kind of heat which you are experiencing would be definitely at a higher side than the previous few days which we used to work out. uh, it's like hundred thousands and million even millions of metric tons of CO2 gets released when we are using the simple chatbots, right, like a chat GPT and all. So they are very simple to use, but behind the scenes if you see their computing, the kind of the energy which is required, it's very huge, and they are burning data centers like anything. So then we need to classify or cluster the entire world into data centers which are efficient, which are non-efficient, which exactly are having more energy requirements, and because of that energy requirements, they have to face these kind of challenges. So that kind of a framework is very much required to monitor these data centers and have high kind of uh, understand the high carbon footprint for these data centers. The challenge is basically what? The reliance on non-renewable energy resources to power the servers. So servers require what? Power. Power is coming from where? The electricity. And when they are getting heated up, the cooling systems are also required. It means that you're having, again, to reduce something, you're also emitting something, and to reduce that emission, again, you're using water, to fetch those particular, things. So we are impacting the GHG also and the water resources also. Cloud providers, despite efforts, are still grappling with how to effectively meet the growing demand for cloud services without exacerbating, environmental harm. So that social cost benefit analysis, as per the UNIDO approach, is required here also, right? So if I talk about a cost benefit analysis on data center usage, most of the times, most of the industries, they simply use a cloud service because everybody is using that. So if they could have used a very simple simulation based environment with local machines, they won't care about that. They are exactly going directly to the cloud and doing those kind of experimentations there, where Microsoft provides certain platforms by which you can have fog computing, connecting your simulated layers with IoT devices, with other kind of hardware solutions, right? By which you can do the same experimentation outside, near to your local, right? Not into the data center. So the major solutions which exactly we need to think is on the base of what goals we are, serving here. So first goal is to reduce the global carbon footprint for data centers through the adoption of renewable energy resources, right? I think the answer currently is everybody's in dilemma. Second is optimization of energy use and deployment of innovative cooling systems. Now, to employ this, also we need to have a monitoring platform. Is the cooling system efficient? Is the non-renewable energy sufficient for supporting my data center? So that these are kind of the two things which exactly I found that these are still, problematic areas which we can have. Now, if I talk about the tech stack which is required on the solution which is required, so we need to have transitional data centers to have 100% of renewable energy, and Microsoft is basically pioneer into that. Implement AI driven energy optimization to minimize energy waste. Adopt liquid cooling and advanced cooling technologies to reduce energy consumption. Apart from that, using folk kind of computing frameworks wherever it is possible for you to work out, right? And then at the same time, how exactly you can use you can leverage green computing or green AI solutions, that also could be checked out. Now, when it comes to green data center and all these technologies, you can see the tech stack is mentioned here. So on a renewable energy integrations, what we can do is solar panels, wind energy storage systems, right? Basically could be major areas where we can operate these particular data centers and we can back up them. Energy management and optimization is required. So AI powered energy optimization systems and algorithms are required there, so that you can manage your entire energy optimization frameworks very easily. I'll give you one hint. If anybody can, understand and would like to discuss that, I can take it further. So let's assume that there is a particular energy requirement at a data center. Now, can anybody tell me that with respect to these kind of data center, energy optimization, how machine learning could be useful, or any example if anybody can quote over there would also be great. So, are we having an interaction with the audience?
No, you can just carry forward.
Perfect, no worries. So let me give the clues, right? So when we talk about machine learning algorithms, what we can do is we can understand that what is my maximum requirement, minimum requirement, average requirement for, the data center. What we can do is, because this energy would be required and would be coming from multiple sources, it could be single source, but also it could be that there could be certain anomalies which would be happening there on the basis of usage. So wherever the usage is going in non-anomalous way, where the usage is working with the average, there is no issue over there, because that's what exactly I need to work out. But whenever there is a kind of a huge shift, or there is a kind of anomaly happening over there in terms of, the usage or the consumption pattern or anything, you can try to ignore, or we can try to identify that how can I fine tune these kind of, what we can say, emergent shifts from these kind of patterns of usages. So first thing is that we need to monitor. So monitoring is the first thing by which you can use machine learning algorithms to check any anomalies happening, to understand the patterns of energy consumption. On the top of it, what you can do is we can optimize the targets in such a way that if I want to keep the energy lowest, and at the same time the consumption, the usage of the services should also be optimum. So those algorithms we need to identify and work out that how can I fine tune these optimization algorithms to see the impact on my the target is going to be what my actual energy consumption which is happening over there. How do I optimize? So there are multiple school of thoughts. Bayesian regression models can be implemented. Deep learning models can come to play there. Time series based models can be checked out, and with respect to the timeline you can see the optimization possibility over there. These kind of things I'm talking about that we can definitely focus in the optimization section, which is more towards working in terms of the kind of computing powers, right? Green data centers, if I talk about the edge computing, energy efficient hardware, sustainable cooling systems are required. So that is another requirement which is going to there. Very important thing which exactly would be the part of demonstration is that how do we carbon track the carbon track mechanisms, emission mechanisms, and how do we report? So first things first is what we need to identify that where the emission is happening, from where the emission is going to be xyz, and how do I optimize. So optimization is the second thing. The first thing is that how do we monitor that. So let's come back to a particular discussion here, and let's focus on Microsoft platform for these kind of monitoring. So let me begin with Microsoft Sustainability Manager. This Microsoft Sustainability Manager is going to give you the entire inside out of how you efficient you are in terms of your green practices. So I'll tell you where the data comes in, how what kind of analytics you can have. So therein. So if you're having a data center or you're having your own premise, right? You can see that whatever services or the configurations you're using, you generally get executive dashboard for the same. So this executive dashboard is what it's going to give you the complete glimpse of what kind of reporting I can have for the entire year. So we can have a reporting layer. What we can do there is we can have the control of the audits, and it can also streamline our reporting process over a period of time. And we can also have these reportings with respect to year wise kind of roadmaps. So each year can be broken into periods that we can open and we can close as per our requirement. So we can create a reporting layer on the top of it, right? Basis that the executive dashboards start working upon. Now the moment it takes timeline to generate my reporting years, you can see that it has got reporting years, region mapping, structure, facilities, even the carbon fee which is involved over there, right? So I'll discuss that. What there is something known as scope 1, scope 2, scope 3. These are multiple scopes which exactly you'll find when you're monitoring your software practices or cloud service practices or any hardware usage or anything. So scope 1, 2, 3 are the elements coming from the major Paris Agreement kind of initiatives, as per the United Nations Climate Change kind of committee framework, which says that we can divide the entire consumption, or let's say emission majorly, into three scopes. So we can target them accordingly. So what comes under scope 1, what comes under scope 2, scope 3. I'll also have a discussion over there itself. Okay, so what you can see is that we have executed dashboards. We will be having uh, emission insights. So this emission insights, when you see, there also would be requiring your reporting layer. So let's let's assume that I create a report layer, and let's say I created report 1, and I started from 2nd of this month, and that you can start looking at. So you can save it over there. So what happens over there is you get a report which has its end date, open date, etc., and then you can start mapping those particular services where your data center, or let's say the location of your service configurations are majorly working upon. So let's say I have United States, right? So if I go to United States, right? Okay, it will ask me to sign again. Okay, let me come back. All right. So what exactly you can do is you have certain certifications which are there, which exactly are specifying that what exactly can be worked upon, how exactly you're gonna build it. You can also get the water insights, the consumption of the water which is happening over there, the waste insights, the digital waste basically, which exactly are also going to analyze your environmental footprint with the interactive data visualizations, right? And then over that comes the entire, reporting. So you have waste quality report, you have circularity report, emission reports majorly. All these things would be up and running. So now these particular platforms are very much in place, which exactly helps you to at least monitor these things, right? So what you monitor is like you have direct emissions, which comes under scope one. We have indirect emissions, which comes under scope two. We have value chain, or let's say you can see that this is basically supply chain and the value chain concepts comes here. So upstream and downstream based activities happening in the value chain system, that comes under scope three. So these scopes are basically coming from where? Coming from the the Paris agreements, where you are defining that how exactly my emissions are there, what kind of emissions are there. If it is related to my direct project or related to my project, it is a direct emission. Indirect emission is what, and all that. So we'll come to that. But now let me give you a brief that how exactly all this looks like, right? As of now, I just created, let's say, a few emission dashboards, right? I need to work out on the calculations. I need to see that I can work out on my energy data, water data, waste data. I can keep a track upon those particular aspects, right? So what kind of agreement details are there? What kind of energy contracts are there? Everything is being captured over there. We have calculation layer which talks about scope 1 to 3 items, their particular emission aspects. We have value chain based aspects where you can work out on your getting third party data sets also. You can even import your third party data sets also from here. Suppose you are leveraging certain third party services, and that service you are leveraging for monitoring your, what we can say, the entire dashboard aspects basically on the carbon emissions, or basically the energy consumption. So those can be also leveraged there. But how these reports look like, let me show you the direct way out, right? So okay, so this is my organizational input, you can see. So as of now you can see that there is an emission impact dashboard, right? So let me also show you direct. Mm, let me open. So I'm opening up Fabric and getting it with my given account. So in Fabric, I think everybody is aware that we have Power BI, right? In Power BI, you will find that you have emission impact dashboards, which you can up, right? There is a kind of a process which you need to do. API based access also will get. So what exactly this dashboard does is it works on emission calculations from your cloud usage. As of now, I'll show you that how exactly it's sample data you can connect with. At the same time, this could be also in your real-time data. For that, you may require your IT admin team to give you the credentials. So you can directly connect your data here on this emission impact dashboard. You can see there is something known as scope 1 and 2, scope 1, 2, and 3 elements, right? Direct and indirect and value chain based aspects. So let me show you what exactly all this thing is about. So when you see the kind of Microsoft Cloud Carbon Accounting practices, a scope one which is more direct is where you're having emissions happening from diesel generators, warehouses, right? All these kind of areas, right? When it comes to scope two items, basically you can see that it's more coming from indirect aspects, the energy consumption from the let's say renewable sources. It could be scope 3 which is indirect. So if you're now supplying, you're practicing or you're using the getting the emissions because of transit of your goods or services, it also results in kind of emissions. So that could be also checked. So direct emission, indirect emission, and let's say other indirect emissions, which is including value chain operations. So if you see the breakdown of these kind of scope 1 2 item and 3 items is, as a server manufacturer, scope 1 and 2 is coming from DC hardware manufacturing. Microsoft Cloud Services is scope 3, which is value chain based operations. Similarly, cloud customer basically is kind of, in this case, it's going to be scope 3 upstream. So likewise, you can see the cloud operations basically will have scope 3 as a downstream for server manufacturer. For Microsoft, it is scope 1 and 2 if it's a cloud operation. So like that, you can see in what areas you fall in. And there's a complete mechanism. How do you calculate that, right? So what is carbon emission? It's in metric carbon dioxide emissions over there, metric tons, change in carbon emissions, carbon intensities, and all. So wait for the session, you'll get to know all these aspects. I hope the session is interesting. You are able to understand that how do we identify these kind of scope 1 2 3 items basis the business activity, and let's say operations of my the kind of day-to-day activities over there, strategic, operational, tactical. And then we need to come to a monitoring platform, so that at least in building those applications I may require these kind of inputs. Then only we can optimize, right? Without understanding what you emit, you can't use that, right? How exactly you can optimize these emissions. What it does, it is especially helps you to save your carbon, it helps to save your energy, it helps to save your money as well, because FinOps is also associated. Rashmita, we are good, right? We are getting
Yeah.
anything from the audience? Yeah.
No, we are good.
Okay. At least Rashmita, you are enjoying the session, right? So
Yeah. Yeah.
okay,
Absolutely.
perfect. So now let's further dig it down, right? So if you see my cloud preparation report on GHG emissions, right? You can have yearly, monthly, and quarterly trackings. So you have a subscription ID in Azure account. You have a year, you have got a subscription name, you have got Azure service name, region, then scope 1, 2, 3. What are the emissions over there in metric CO2? That's metric ton CO2 that would be highlighted here. So there you can see that is what exactly get into. Now you'll be asking me that, hey, we are working on all these calculations, isn't it? Like, for example, my containers are there. I mean, there are 206 services over there, and even more than that, right now in Azure. So for every service, you can identify what is the emission happening. Now, what is the use of it? So the use is very simple. There are certain benefits which are associated with carbon credits that I'll discuss the next. And there is obviously the planet badly needs these kind of operations, so you can at least drill down your non what we can say, sorry, non-required resources, so you can optimize your consumption of services. So if there are 206 services, not I'm working on every service or every day, so why don't we have a kind of a management over there where we can reduce over these kind of emissions by reducing those service requirements and being dependent on them when they are not in use, right? So we can optimize our energy consumption while using these kind of inputs. Now I'll tell you how we can use this. So let's create this platform is created by Green Foundation, right? I hope everybody is aware of Green Foundation. They are leveraging all the cloud platforms and then generating these kind of fantastic visuals in terms of getting those kind of calculations outside also. But when it comes to Microsoft, it has already given those kind of inputs. But just to begin with, if I were to use Azure cloud platform or anything, what I would do is I'll check that what is my runtime of a machine, what are types of cores I need, CPU, GPU, TPU, whatever, number of cores to be utilized, model could be changed, right? Memory which is available, and then is it local server or a cloud computing? If it is a cloud computing, in that case, which cloud service I want to use? Let's say Azure. I'll select a location, right? Let's say it's around United States or Africa around, right? So in Africa, if you see, right, you would see that the major uh, areas which exactly see the footprint is Australia, then India, China. The reason is that it directly or indirectly has other emission which is getting impacted. So that you can select, and basis that you can get your computing cores versus memory workarounds, how much CPU percentages they're contributing to the emission, and memory wise what is the contribution, location wise then you can get the footprints. So if I use this kind of a configuration, I actually have emission, which is equivalent to 1.513 months carbon sequestration, which is happening from a tree. It's emitted by 7.91 kilometer of a car passenger car is running. It's to that equivalency. 3% of consumption which is happening in there from while having a flight running from Paris to London. This cloud service basically is giving me that emission, isn't it? So we can directly use this kind of carbon equivalent aspects, and which makes sense to understand that how exactly then what kind of emissions we are doing having within the cloud also. So though you're not running a car, you're not flying, still you emit that much. That's what exactly is proved here. But let me come to something. So this equivalency all you can leverage as well in carbon optimization service on Microsoft Azure. Microsoft Azure basically comes with emission details, emission trends, and this basically, if I'm not connected to my real-time data, otherwise it could be directly generated, but because of the kind of security reasons and all, we cannot directly showcase. So, anyways, but you can see that what I can get is I can get total recommendations, potential monthly emissions reductions, which is happening over there in kilogram carbon dioxide emissions, estimated one. This is the equivalency, right? So we can change this equivalency also from bus, car, or whatever exactly you're gonna use, and how much carbon is being emitted for that particular thing. So you can see that indirectly, virtually, that how much carbon is being emitted while using these services, right? So many things would be going into your mind that hey, this carbon optimization I'm showcasing, the dashboard for uh, cloud service usage I'm showing. What is the connectivity over there? So there is a connectivity. I'll discuss that, right? But as of now, let's understand that. First of all, let's begin with connecting to our data, because data is the asset, right? This data only would be helping us to understand how the solution should be built up. So first thing is monitoring part. Coming back to the discussions over there. Now, there are certain libraries and packages and SDKs also which are available. You can directly make use of them in Pythonic environment or .NET or whatever the platforms you are interested in to work upon. So that also can check out. Mm, I think there's okay. Coming back to my screen, Rashmita, a quick confirmation that we are again on the slide. Am I audible?
Yes, you're audible. Please go ahead.
Okay. Now, so if I talk about the kind of the first problem statement which I just discussed is basically around what we should say is the high carbon footprint of data centers, right? So basically, that is the major challenge which exactly we are working right now. And how do we start working and getting it optimized is to first of all start monitoring. Once we start monitoring, then we can go for optimizations. How do we optimize? We then have to leverage certain algorithms which exactly would be facilitating the kind of the calculations, making it optimized from the target perspective. What is my target? If I'm using, let's say, around, let's say, XYZ percentage of energy this year, if I want to cut it down by 20% next year, so how I can keep it optimized when my customers are also increasing, which are using cloud services, right? So keeping that thing in mind, how do we optimize? There are multiple factors which are involved. So there are the factors also we'll discuss right now. But before that, I need to get into the second problem statement, and that is very crucial again: the e-waste, which is generated by rapid hardware upgrades. So the major demand for this kind of cloud computing also is creating dependency on hardware, and this hardware rapid obsolescence also could be resulting into electronic waste. So ultimately it's directly proportional to consumption or the services increase within the global purview. So this is how exactly you're going to work out that I have to identify that what kind of hardwares are utilized, how then we decompose them, and how to reduce those kind of digital waste. This is one of the hardware waste. But if it comes to e-waste coming from non-usage of cloud service, that is also kind of a wastage. Suppose I need $100,000 kind of a cloud service, That's the budgeted service. But for weekends, I'm not using that. For certain hours, or let's say certain seasons, I'm not using that. So it is complete waste for me. So I have to see how I can automate those transactions, how I can leverage latest AI solutions to optimize those particular things. So before that, we need to see the key statistics. Global e-waste has reached around 53.6 million metric tons, and they are going to increase further by 74 million metric tons by 2030. Challenges: obsolete hardware, working equipment redundancies, replacements, lack of effective recycling programs, etc. And as I mentioned that keeping the particular computes and servers up and running when they are not in use. Also, we need to identify which service contributing more towards these kind of emissions, right? Then only we can make it perfect. Key solutions are like we can have some kind of refurbishment programs, hardware recycling aspects, e-waste management aspects, which can be integrated. The kind of tech stack which you see there is requiring hardware lifecycle management, e-waste recycling and disposal systems, cloud hardware management, sustainability tracking, and all. So we can have IoT-based environmental sensors. Blockchains could be there, for supply chain transparencies and environmental impact dashboards, as I showcased to you, would be the answers to these kind of, at least calculations of emissions. As I mentioned over there in one of the demonstration, that we can select the hardware which is being utilized, and basis that then we can start calculating. So these are all available. Lack of transparency in cloud emission reporting. That's the another challenge which I found as per the research works. So you can see that most of the cloud providers, they claim to adopt sustainable practices, right? But there is still lack of standardizing the reporting. Every year, all the cloud platform they submit sustainability reporting. So Microsoft supports that particular agenda regularly. We are submitting our, let's say, PUE scores, right? Power consumption, what is the power usage efficiency we have. So that particular thing is to be leveraged. How do we calculate? I'll showcase those metrics. How do we calculate PUE scores, as I mentioned? So this reporting is very much required. So let me take you to that. If I talk about any cloud, let's take Microsoft sustainability report, right? So there you'll find that Microsoft sustainability report. So 2024 report is here, guys. So what you can see is that we have the global fact sheet. Seems to be. So we have the entire report on how can we advance sustainability from Microsoft. Now, this is a transparency. It means that we are showcasing how much contributions we are, you know, having in terms of working on carbon, waste, water consumption, ecosystems, customer sustainability, global sustainability reportings. When we are using these particular platforms, is it sustainable? If yes, to what level? What is our approach? What is our PUE score? What is our average PU which we're gonna work out with? Right? So there are certain areas which exactly we're gonna work out with. Now, if I talk about the sustainability reporting, you'll find the entire aspects that how exactly the things are changing over there with the leadership. So you can see that we are improving measurement, increasing efficiency, forging partnerships, building markets, advocating for public policy changes, right? This is what exactly are the major assumptions, which exactly, sorry, strategies which Microsoft is working right now. Water positive means they're taking holistic approach to becoming water positive, which includes water access, replenishment, innovation, reduction, and policy. So this is requiring optimizations, right? So this is a global concern these days. We need to have zero waste, right? So by 2023, we achieved a reuse and recycle rate of 89.4% for servers. So suppose if anybody is coming to you and say that, hey, for my industry, I want to build up this platform. So what you require is you require understanding of the scope 1, 2, 3 elements and the metrics, that how do we calculate these kind of metrics. And post that, then you can offer the solutions in terms of ESG practice to sustainability solutions to working out on reducing the digital waste or the e-waste, how we can optimize water usage, carbon usage over there in terms, sorry, carbon emission over there in terms of the data center or cloud service practice, or even in the software operations, as I mentioned, isn't it? So these are the practices for tracking the sustainability. But my agenda was that most of the times, okay, the screen is taking time. It got dead or what? Let me come back. So we were at the problem statement number 2, and this is what I was discussing. That lack of transparency in cloud emission reporting is also causing the problems. So we need to have certain tools or platforms by which we can monitor them, even if the reportings are not there. So, for example, as I mentioned, using satellite imageries, using drones, using your other aspects, you can understand that what is the emission happening in that given region. Recently, I worked on a paper which exactly mentioned that they are calculating emissions of retail outlet from the physical data centers, understanding what exactly is the emission happening over there on that given region. So these are the kind of tech stacks which you can leverage. So we have carbon estimate emissions measurement and reporting, which has carbon emission footprint APIs. Microsoft provides that. Emission analytics platform, as I mentioned, sustainability reporting tools. Uh, then we have cloud monitoring and tracking, and multiple as such. So let me magnify. All right. So this is what exactly you're gonna see, that I have all these particular platforms and tech stacks, which exactly would come to play when I'm consuming the particular services for my emission checks, right? So what are the solutions? Number one, let's leverage carbon emission measurement and reporting, as mentioned. Let's have a blockchain for transparency. We can have blockchain based reporting. Contracts could be studied. Smart contracts could be built up for emission verifications. Environmental impact dashboards, as I showcased, those to be leveraged. Third party auditing from, let's say, carbon auditors, certification from ISO, that is 14001, VCOP, etc., could be leveraged. And it could be some independent verifications. AI assessors also could be there for leveraging these kind of solutions and tech stacks. Then comes the few more things like the scalability and sustainability of, what I should say is that, how you are using your cloud services. So let me see why it's not coming to the presenter mode. Hmm. Okay. Anyways, I think there is some kind of compatibility issue over there with Teams. I'll magnify and will showcase, guys. So I hope we can see that the problem is scalability versus sustainability in cloud services. So how do we make the solution scalable? So scaling cloud infrastructure solution, basically what they require is they are going to create some kind of energy inefficiencies and resource wastages. If I want to, if my customer is there, right, it is looking for a kind of a solution, I have to improvise or increase the cluster size, or let's say my compute size, without consciousness, and let's say without conscious efforts. If I randomly do that, doesn't make any sense. Ideally, what should be the case is, I should know that when I'm increasing the compute size, it comes with a cost to the nature, to the client, and obviously to the society. So how we should keep that sustainable also requires some kind of conscious practices. Otherwise, data centers cloud practices would also be the next level of emission creators, which exactly would be turmoiling the entire climate. I would say that it is only 1% right now, but it's increasing over a period of time. And not only that, let me come to showcase some basic aspects, and then I'll come to the FinOps angle of it. So if you see the global contribution there, right? So as of now, you can see that we have different contributions, right, across the industries. The major contribution is happening from where, the major contribution is happening from energy uses, right? So you can't say that it's not there from other areas, right? Why we should be concerned about cloud services when they're only 1 to 2%? Because 73.2% comes from energy, isn't it? Rest of the areas, even agriculture emits 18.4%. Landfills, wastewater, etc. is 3.2%. But since we are actually into technologies, we are building these technologies, we are contributing to these areas. Why not take initiative and let's make the entire technology green and clean, so that when we use these technologies for working on energy segment, they can also be monitored well, and then we have certain alternatives. So I understand that it is not 1% versus 73%, it's a big gap. But it's still I would say that we need to have call to action for this, and we need to set the benchmarks as we are dealing with the standard practices. Already we are working on sustainability side. Let industry of practitioners who are using cloud services, let them set up a kind of a stage for a global audience. I'll show you what exactly could be the next level of challenges you're going to face then. Now the next challenge you would be saying that, hey, if I use this, uh, the finance is going to be impacted, right? And at the same time, my scalability would be impacted. So thinking into that area also, what you can do is you can also have FinOps practices for cloud service users. You need to optimize your cost, you need to optimize your efficiencies and sustainability in such a way that you can really reduce the impacts which is happening. So 30 to 40% of cloud spending is wasted nowadays. 25 to 30% of potential service can be also achieved, nowadays through resource optimizations and better cost allocation practice. It means that on an average, 25 to 30% I have in my hands, where I can safeguard the coast also, safeguard my climate also, and safeguard my industry also. So how are we gonna do that? We gonna leverage those services from Azure, which exactly gives me the way out to deal with this very easily. So we have certain services, guys. We have resource optimization services which we need to implement on AKS, Azure Functions, ACI, etc. We have to work out on cost management perspective, leverage these services so that you can understand what is the current consumption happening there from GreenOps to FinOps perspective, especially on FinOps side. Cost management is very, very important. There is one more service which exactly I would like to recommend before dealing into anything. Azure Advisor. Azure Advisor, basically what it does is it comes with its own insights. It's a generative AI powered, kind of a platform which you can use and can generate recommendations upon. So that's what exactly is required. So when these particular challenges which you face regarding sustainability, regarding carbon footprints, what we need to identify is that let's bring a sustainable solution platform, and that solution platform would be consumed by our clients or our industries or my business activities, which we exactly am leveraging that. And let's try to show that reporting to the global world that we are actually safeguarding uh, the planet from emissions of these kind of GHG aspects. So I think that would be easy for everybody to scale up. Now the major challenges, if I talk about, is that what are the global standards which are set over there, isn't it? So as I mentioned that there are certain global standards which you need to work out from the calculation perspective to optimization perspective. So what are the major aspects? Greenhouse gas protocols are there, which exactly you should use to identify scope 1 to 3 elements, right? To identify the direct emissions happening, indirect emission happening, and the other supply chain based or waste disposal kind of emissions which are happening. ISO 14064, greenhouse gases being defined there. You need to follow those standards to have this kind of informations in check. Carbon disclosure project, basically CDP, is you to have a kind of a framework which you can use. PUE, this is what exactly is very important. Power usage effectiveness and efficiency is towards identifying that how much power is being utilized in a best possible way uh, by the data centers, and they are green or not. So PUE should be around 1, right? That ratio should be around 1. That is what exactly Microsoft will say, is that we will be carbon negative by 2030, and the ratio would be 1 is to 1 when it comes to PUE. So total facility power divided by IT equipment power is the kind of a formula for this. We need more energy efficient data centers, and that should have lower PUE scores, isn't it? So even if it is 1:1, that is also fine. So it's in like neutral, carbon neutral, you can say. So that's what exactly is the case. The climate neutral data center pact is also there. We have voluntary commitment by cloud providers to achieve carbon neutrality for the data centers by 2030, isn't it? So that also we need to work out. Just give me 1 second. Right. So that's what exactly is happening there. And if you go ahead further, these are the key metrics which exactly I have identified, innovated from my side as well. And this also we need to keep a check upon. So if you can see my screen, you can find that there are certain metrics for energy usage efficiencies, power usage effectiveness, carbon usage effectiveness, server utilization rates, virtualization ratios, data storage efficiencies, renewable energy utilization over there, electronic waste recycling rate, cloud resource optimization, cooling efficiency ratios, network energy efficiencies, and greenhouse gas emission reductions. Which means that if I'm able to quantify them, I'm able to report my, what we can say, the entire sustainability aspect, FinOps aspect, and the other aspects, right? And then we can monetize these particular opportunities with respect to the better maturity of my global green practices. It's not only green practice, it is also the cost saving aspects. It means FinOps practices. So GreenOps and FinOps both are getting targeted when exactly we're working on these kind of KPIs. And these particular KPIs are very much in turn helping us to have a wide range of framework for our calculations on Azure. So for example, if I want to calculate energy usage efficiency, I can use Azure Monitor, Azure Cost Management, and Billing, which helps me to get IT energy efficiency and facility energy usage details. Power usage efficiency can be calculated when I can have total facility energy divided by IT equipment energy. For that, I need to leverage services Azure Monitor, Cost Management, and Billing, where I can get the details on facility energy and IT energy. Carbon usage effectiveness also is calculated by this formula, and these are the kind of softwares, or let's say the platforms which we can leverage, services we can leverage on Azure. So we have Azure sustainability calculators, right? So these are the ways and means by which you can keep a track on these metrics. These metrics are again nothing else but I have drilled them down that how exactly you can say that this is scope 1, 2, 3 item, and this is what metrics I am actually comparing my different services, and then you can see choose the best services which has the least or optimum utilization of these kind of metric scores. So service server utilization rate should be 100%, right? Virtualization ratio, if it is down, what you need to understand is number of virtual machines divided by total number of physical servers. If it is less, how can I keep it 1:1? So in that case, you can also take help of generative AI mechanisms. You can have agents to work upon, help you to recommend those solutions that you can recommend those particular right sizing of your computes. So majorly it is around right sizing. How exactly we can have right sizing of resources which are being utilized for virtualization, for data storage. In data storage, I need to check that how much data is useful, which is there in my storage account, right? And if it is like useful data stored is 50% divided by total data, so it means that there is 50% efficiency happening, isn't it? So I need 100% efficiency. For that, I need to have every data which I'm using should be useful for me. If it is not useful, just delete that or try to have a different backup mechanism done to keep it on a cloud side. So Azure Storage Analytics is there where you can do that, right? So ideally what is happening is whatever the metric you see, they have their own consumption patterns. They are very much specific to customer to customer, industry to industry. So what I've done is I have divided this particular entire industry into different maturity levels, and basis that you can see what solution framework could be utilized for them. So for example, if you see now the screen which is up with maturity levels, there is a foundational maturity level, developmental maturity level, operational, optimized, and transformational. Five different layers of maturity which I have identified. This is again you can see it is innovated from my side. So basis the kind of the practices which I see over there on a regular basis. So I can see that the foundational maturity levels are nothing else but the basic infrastructure setup, which with respect to data collection, some of the industries would be using IoT sensors, satellite data. Some of the industries would be just starting collecting that. So it's only working on foundational level. Then developmental aspects, when it comes to we need to work out on those areas where the AI is already being adopted. So here it's only data layer. People are working with AI driven solutions in the next layer, and at the operation level you'll find that they have scaled this particular utilities to the next level. So if I move, okay, I think there is some issue in Teams today, SharePoint today. So if you can see that operational aspects are where the consumers, or let's say the the service users, they're having scaled integrations of agentic AI systems, real-time emissions monitoring, etc. They have implemented collaborative data sharing protocols across the industries and regions, but are not having optimized workings. In optimize, what we do is we have predictive powers, we have predictive, cognitive, and prescriptive analytics to refine the sustainable strategy solutions. And those organizations which are actually having transformational maturities, they have set protocols. They leverage GHG protocols, coverage of scope 1 to 3 items. They have continuous feedback and learning mechanisms, to work on these kind of solutions. So basis their maturities, we need to understand that how I need to optimize my cloud environment and best possible integration of GreenOps and FinOps in a combined fashion. There, I think we can come up with the best possible scenarios. Now, to take it further, I would recommend one single solution which you can leverage. So what you can do is let's create multiple AI agents. These agents are taking the information from your machine learning system which you build to track your cloud areas. Let's say it could be hybrid cloud, it could be Azure cloud. Basis that data knowledge base, machine learning models are built up. These machine learning models, what exactly they do is, sorry for a bad thought, they provide the input to the agents. These agents then particularly leverages Azure OpenAI services and can recommend you the recommendations basically with respect to the right sizing of the resources, right sizing of the quantum which is required for the energy, right sizing of let's say the emissions which exactly you should emit in a controlled way, and then the final aspects could be covered up, right? So from that perspective, if you see, there are certain platforms which I mentioned. We have Microsoft Autogen environment where you can create these agents. The new service which is going to be there and very soon is in the agentic AI operations that you can leverage, and where you can build this entire infrastructure and the solution in such a way that you get the best in class outcome when you are actually working on these resources, right? And how do we work out? We create multiple agents. These multiple agents, what they do is they try to collect the information from the machine learning systems where they find some kind of anomalies, and they can suggest the right sizing of the resources. I'll give one more last example, and by that you can understand the every aspect of it. So, for example, I have seen one platform. Let's say what we are going to do right now is that how exactly the right sizing would be there, what kind of recommendations to be generated, all these things on a framework, right? So I'm coming to my Azure Marketplace, and let's take a minute. No internet. Okay, it's there. So we need to build up certain solutions which comes with true carbon cloud optimization and sustainability aspects altogether. For example, this solution, if you see, what they do is basically they have real-time carbon aware computing without budget breaking cost, right? Let me show you the aspects. So Cirrus Nexus and dashboard as here. All right. So if you see that solutioning, okay, it's not visible to you. Let me zoom it out for you guys. So what you can see is that they have data center sustainability mapping. So whatever the data centers are there, you basis their PUE scores, which I mentioned that every organization, let's say data center, they publish their own PUE scores, power usage efficiencies, effectiveness. So that scoring, if it is done, you can map them globally, right? Using heat maps, you can make it more pro. And the second time, what you can do is you can have a framework which basically use all the comparisons, right? You have Azure data center, you have AWS data center, GCP data center, their comparisons. So you can recommend the users that this is what exactly they should leverage. Carbon equivalency, they should showcase that how a cloud emission equivalencies could be achieved with respect to the region and cloud. Most important thing is that how do you recommend the right sizing? So the advisors can be used. Azure advisors could be utilized to have right sizing of computes. So for example, if my deployment is a given instance, it's a monthly spend over there. Energy consumption is this much. CO2 emission is happening on a daily basis is 70.60. Water usage is around 20.14 liter per day. Usage rates are this. Right sizing is basically mentioned as right size risk. If I don't right size, what would be the risk? What could be the saving potential? So it's around 80% or over a period of time for a given instance. So that's how exactly you need to identify that. I not only need to track it, but using the algorithms, using the advisors, using generative AI mechanisms, whatever the mechanism used for recommendation, you need to use that particular recommendation and give it back to the uh, service provider, service consumer, or the provider if you're it's a data center, right? If it's your customer, you can also calculate this and can get into those particular aspects. The last thing on the session is that if I have uh, software, let's say I have got something on a SCI framework, right? So how exactly these calculations work out? So there are certain specifications which are already given by software, Green Software Foundation. Microsoft also leverages the same frameworks, right? Which is basically SCI. Now SCI specifications are nothing else but they're having the entire repo for understanding these particular calculations in such a way that you can make use those particular calculation, the metrics and the methodology to work on the systems to create data center evaluation or individual machine inspection, or it could be cloud service, feedback. So the recommendations are based on what are the total embodied emissions happening, some of life cycle assessments, and the kind of resource share which is happening with the kind of given uh, service. So using these particular metrics which I mentioned and the additional metrics which I just mentioned, you can calculate every service which exactly we're going to use in any of these domains to calculate its software carbon intensity. So that is SCI. Software carbon intensity is basically leveraged by Microsoft also, and we can calculate it for any service which are there for getting these particular units up and running. The quantification is also mentioned there. So these are like basic mathematical formulae and calculations, but they really impact you if you predict them. You optimize the solutions with respect to GreenOps and FinOps. From that perspectives, I would like to stop it here and now heading it back to the team so they can work out with. And there are certain publications which I have there on ITU also recently published on paper, which carries the entire information on how exactly this is yet to be globally available. It's in the review mode only, but yeah, you can see that how agentic AI and generative physical AI could be a novel framework for sustainable emissions monitoring and management, isn't it? And there you will find all this kind of releases with respect to the major aspects of monitoring. So the major findings would be there. We'll be sharing this within the community, and you would be able to access the same. So different layers of services offerings, which basically comes with what layer of integrations and what is novel over there. You will be able to get it. Thank you so much.
Thank you so much, Dr. Ravi, for this interesting session. And thank you all for joining us today. Please visit Microsoft Reactor website for more upcoming sessions. And we would appreciate your feedback on today's session, and it will help us to curate future session. Thank you all once again, and enjoy the rest of your day.